Hello, welcome. We are going to see the derivation for the T formulas. So we are going to begin with the one in sine. So we are going to say from sine 2x, which is a double angle, is equal to 2 sine x cos x. So from that, we want to derive, so to have our right hand side in terms of tan. So to do that, we need to create, because our tan x is equal to sine x divided by cos x. So we need to create sine x over cos x on the right hand side without changing its meaning. So we shall have sine of 2x giving us 2 sine x divided by cos x in order to create a tan, then times cos squared x. So that if we cancelled out these ones, then it would remain the same. So here sine of 2x would give us 2 tan x, then times cos squared x. So this cos squared x can be converted into sec, such that we use the Pythagoras theorem, where we have 1 plus tan squared x giving us sec squared x. So we are going to create a sec, but we know that sec squared x is equal to 1 over cos squared x. So if we introduce the reciprocal here, if we wanted a cos squared x above, so 1 over sec squared x would be the same as cos squared x. So we shall bring this and then substitute it here, such that now our equation becomes 2 tan x, then multiply that by 1 over sec squared x. And we have just seen that sec squared x can be written as, so we shall have this as 1 plus tan squared x. As so we shall continue here and say our sine 2x is equal to 2 tan x divided by 1 plus tan squared x. So since we need the sine of x only, we are going to divide the angles by 2, only the angles. So we are going to have sine x giving us 2 tan x over 2. Then we divide this by 1 plus tan squared x divided by 2. So we let t be equal to tan x over 2, and this means here our sine x is going to be 2t divided by 1 plus t squared. So this would be the t formula for sine what? For sine x. And after deriving the one of them, so now since we have a sine of x, so we can use the right angled triangle to prove others. Let me draw this one here. Let's do a right angled triangle. So that would be our right angled triangle, where we can now write our angles. So this longest side here is because if this is x, the angle, this is the adjacent, this is the hypotenuse. So sine is the same as opposite. So the opposite is 2t. Then the hypotenuse is 1 plus t squared. So if we find this by Pythagoras, so if we let this to be like a z, so we shall have z squared plus 2t squared is equal to 1 plus t squared. And this one we as well square it. So this would be z squared plus 4t squared is equal to 1 squared plus 2t squared, then plus t to power 4. So this can be written as z squared is equal to, so we transfer the 4 to the other side, 1 plus 2t squared minus 4t squared plus t to power 4. So this would give us 1 plus, no, it will be 1 minus 2t squared, then plus t to power 4. So we can simplify that and write it as 1 minus t squared, and then this way square it. Then after that, we are going to take square root both sides to find the value of what? Of z. So taking square root both sides, our z is going to be 1 minus t squared. So we can redraw our right angled triangle and then have all our sides being named. So that is our triangle. After getting our triangle, this was x, this is 1 plus t squared, this is 2t, and this is 1 minus t squared. So from here, we can get the t formula for cos of x. We know that cos is equal to adjacent of a hypotenuse. So this would be 1 minus t squared divided by 1 plus t squared. Then the one for tan, we know that tan is opposite divided by adjacent, so this would be 2t divided by 1 minus t squared. So this will be our values. So that is how we do how we get or how we derive the t formulas for sine, cos, and tan.